Good evening, everyone. Welcome to the Ember System Masterclass series. Today is day 9. I warmly welcome you to the session. Thanks for coming and thank you for your time. So, first, I would like to thank the Andhra Pradesh State Skill Development Corporation for the support for this program. And let's go to the session. Today, we are going to learn about the introduction to LCD, like what are the types of LCD, and the pin details and pin descriptions, and how to connect LCD to 8051 and how to program and how to display the characters. Okay, and the second session we will be covering up the I2C interface with 8051, how to interface I2C EEPROM like 24C04 to the 8051, and we will be covering up the pin details, schematics as well as the program. Okay, so these are the things which we are going to cover up today. So let's have a great session. I'll give a short introduction about Pantech and about me and and the announcement, and we can go to the session. Okay, so Pantech was started in the year 2004. We basically manufacture embedded motherboards, and we do also manufacture a lot of lab equipments. So if you want to know more about our products and services, just log on to our website pantechsolutions.net. Okay, so my name is K Jeeva Rajan. So I completed my masters in the year 2002 and my 2004 and my bachelor degree in the year 2002. I have put my LinkedIn link in the description box. If you want me to connect, you just send me a connection request. I'm happy to connect and happy to help. So coming to the announcement, the attendance link will be available at 9 p.m. Minimum attendance required for an e-certificate is 27 days. Okay, for 27 days. For internship candidates, no need to fill the attendance form. So for the lab sessions, we'll be using the recorded video streaming for improving the learning experience. And for 8051 5-day workshop, use the same attendance form. You could use the same attendance form. So you'll be getting the certificate at the probably on tomorrow evening. So coming to this internship, you could avail the 30 days internship. We have you get 30-day video coaching lessons, which is valid for 6 months, and you have weekend live Q&A sessions for every Saturday at 11:30 a.m. and you get the digital workbook and internship certificates. 10 plus projects, you get 10 plus projects as well as the sample resume, and you get PPT download as well as the source code download and schematic downloads. Okay, so all this available for 590 rupees. So if you want to enroll on internship, you could enroll for internship. This is the best investment you could make. So coming to the mindset lesson, let's start the day with the mindset lesson. So take action towards a goal. Okay, take action towards a goal. That's the first key steps to success. So if you don't fill your day with high priority actions, then automatically it will be filled with the low priority distractions. Okay, so today exercise is to write down everything that creates a resistance in the process of taking action. So I have given the document on the Learn portal. You just download and print it, and you just write down the resistance, whatever it may be. Okay, you write down all the resistance so that you will be aware of what are the resistance you have to remove it. So just fill the day with high priority actions. If you are not planning the day, then it will be automatically filled with the low priority work. Always know where to go, what is the plan and what you want and what you want to achieve. Then list down the actions towards the goal and just take actions on that goal. Actions on the goal. So this is the mindset activity today. Go to the session. Today topic is LCD. Okay, first we'll go with LCD. So LCD, it's a liquid crystal display. And it is available on monochrome, and it is available on color, and it is also available as a panel. Okay, LCD panel. So today's session, we are going to cover up 16x2 LCD to interface 16x2 LCD with 8051. It uses the polarizers. Okay, and it has a background light. It has some LCD comes with background, and with even there are LCD which is available without the background. So we are going to take 16x2 LCD, the first one, and we are going to interface with the 8051. So coming to the pin details, when you check the pin details of LCD, you have this is the pin details. VSS is ground and VCC is 5 volt, and VE is again like it's an adjustable voltage, okay, which you give for contrast control, and RS stands for register select, and RW stands for read and write, okay, read and write, and E stands for enable, and D for data. Okay, it operates on two modes, like 4-bit mode as well as 8-bit mode. You could use 4-bit mode or 8-bit mode. So today we are going to cover up 4-bit mode. It means we are going to use, out of this 8 bits, we are going to use 4-bit. By using 4-bit, you could display the data. Okay, and this LED for the background. Okay, LED 5 volt and ground. This is for the background light. So the register select, you could give command as well as data. So if you give command, the register select should be 0. If you give data, like the register select should be 1. Okay, the LCD module accepts both command as well as data. If you give command, it should be 0, and if you give the data, it should be 1. For read or write, it could read the data or write the data. Like read, if then it is 0. Sorry, write it is 0 and read it is 1. So we are going to use only write, so it will be 0. So for enable, like LCD enable is to low to high pulse of 3. You should give a low to high pulse of 3 milliseconds. Okay. So D0 and D7 are the data pins. So for 4-bit mode, we'll be using this D7, D6, D5 and D4. We'll be using D7, D6 and D5, D4. So we are going to use 4-bit LCD today. So I'm going to choose a 0 port 0, where I'm going to use port 0.0, 0.1 and 0.22, RS, RW and enable, and 0.4, 0.5, 0.6, 0.7 to this D4, D5, D6, D7. This is the circuit diagram, like for connecting the LCD display. So you have to give a 10K resistor for the contrast adjustment. Okay, 10K pot meter. You have to give a 10K pot meter on the VEE pin. Okay, that's for contrast adjustment. And for LED plus and LED minus, you could give, for LED minus you could give it to ground, and LED plus you could give it to 5 volt. Okay, VSS is ground and VCC is also 5 volt. So you have to connect VCC EA pin to 5 volt and the reset circuitry and the crystal circuitry. Okay, so this will work. So these are the character display, like to display 1, 2, 3. Okay, so we have only 4-bit, but when you want to display A, it should be like the hex value will be 8-bit. Okay, the hex value will be like the binary value of the hex value will be 8-bit. So you have to, this is the upper data nibble. Okay, for example, you just take the value for 1. Okay, just take the value for 1, this to 1 and 2. Okay, the 1 is 0011, and like the upper nibble is 0011, and the lower nibble is 0001. Okay, the lower nibble is 0001. The hex value is 31. You have to send the hex value 31 to display the data 1. Actually, it is 1 here. It is 1. The next is 2. The next is 2. The 0011. Okay, 0011. The upper data nibble, and the lower data nibble is like 0010. Okay, 00 is 32. So A, B, C, D. Okay, so you could give the hex value, the ASCII value of the hex value of the ASCII value. Okay, to display the LCD. So let's go to the code. First, I will explain the code on the presentation. Then we can go for the tail version, and I will go step by step. Okay. The first is hash include reg51.h to include the registers of the 8051, and stdio.h like a standard input. If you are going to use printf, then you have to use this header file. Okay, has defined data p0. I'm just declaring port 0 to data. I'm going to use port 0 for LCD display. So I'm just declaring data to the port 0. Okay. S bit is like S bit is to configure the RS and like RW and LCD to the ports. Okay. Like to P0.0 and 0.1 and 0.2. Okay. 0.0. I'm assigning 0.0 pin to RS register select, and 0.1 to RW, and 0.2 to LCD. Okay, and just declaring a message for displaying the first row. There are two rows here. Like for first row, I'm displaying A. In the second row, I display CD. We could change the message. Okay, so you could display 16 characters on both, like on both rows. Okay. These are the functions: LCD underscore init and LCD for sending the command and for display, and a delay. Okay, for to give a delay. So for command, like RS equal to register select is 0. So that for command, like if you check here, command RS equal to 0. Okay, RS equal to 0. So and RW equal to 0 and LCD equal to 1. Okay, it should be from low to high. The enable should be from, initially it will be low to high. So 0. So you have to enable this one. Give a delay of 35. Okay, delay, and this is for data. For command, this is to take the upper nibble. Okay? F0, like it will take the binary value of F0 will be 111000. Okay, and for this is to take the upper nibble, and for the lower nibble, like you just shift it 4 times. Okay? Shift it 4 times, like you will get data here of the command of the data of the lower nibble. Again, RS equal to 0 and RW equal to 0, LCD equal to 1. Okay? Delay milliseconds of 35 and LCD equal to 0. So this is to send the command. So data is assigned for port 0. Data is assigned for port 0. So this is for sending the command. You just copy this one, same thing, and you paste it here. Display. You get LCD for for data. For data, just modify RS equal to 1 here. The rest of the code is same. Okay, rest of the code is same. And delay. This is just for a delay. Like if you give 100, like it will give you like delay in milliseconds. Okay. So this is the initialization code. So this is to display like LCD underscore like command. These are the commands. First we have to send the command, like what type of LCD it is. LCD is that. So 2 into 16 characters is 28. Okay, these are all the default commands to display on the cursor of, like the default command is here. The default command. Okay. So the default command is, I will show you the default commands. Okay, default commands of the LCD. I'm searching 16 cross 2. Okay, 16 cross. So these are the default commands, like clear display screen. Okay, so these are the default commands, important command codes for LCD. Okay, so clear display screen, return home, and for force cursor to the beginning. Okay, force like 38 for 2 lines, and for some cases like it is 28, and some cases it is 38. Okay, you have to check the data sheet of the LCD which you are using. The LCD which I am using is 28. Okay, 28 for the command is 28, and for force cursor to the beginning is 80. Okay, so display on, cursor blinking, shift, display off, return home. So these are the clear display screen. Okay, these are the commands. Okay, so 28 is for 16 cross 2 LCD, like, and you should make a delay. Then display on cursor off. The command is hex of 0C, shift cursor to right is 06, and clear display screen is 01. Okay, you have to pass this command. Then for first line, if for displaying in the first line it is 80, for displaying the second line it is C0. Okay, you have to pass the command delay for 80 for displaying the first line, and while of the message till the ends. Okay, till equal to 0. It displays the message. Okay, it displays the first message, and the same thing you just copy and paste it here. You just change the command to C0 for second line initialization. Then like LCD display, okay, it displays the second message. Okay, so for coming to the main program, like initialize port 0 to 0, LCD underscore init. So you call the delay and while of 1. Okay, so I'll run this. We'll go for the kill. I'll go by the program step by step again, so that we'll be very familiar with the program. So I open the Kale. I'm opening Kale now. I'll change this to okay. So the first thing, I'm going to create a project. So first I'm going to create a folder here called LCD. Okay, copy the path, and I'm going for project new microvision project. Okay, change the folder and give the name LCD W78E05 2D. Okay, just choose this. I'm choosing this IC. Click no. So first you have to add the C file. I click add new items, choose. Okay, choose a C file here, LCD. Okay. So save the program. Hash. Just first thing is to include. First thing is you have to include the register file. Okay, rich51.h. Okay, then like include stdio.h, hash define like data, you declare a variable data. Okay, p0. Okay, s bit like s bit of rs equals, like you have to declare like what port is that. Okay, I'm going to assign p0. Okay, of 0. So this, it should be on rich51.h. To open rich51.h, you open rich51.h. So it will be here. Okay, you use the same thing, p0 p1. Okay, so p0 so I'll make this as RW read register select. The first one is read write, and it is LCD. Okay, LCD enable. LCD enable. This is the second pin. This is the second one, and this is the first 0 1 2. Unsign, you just unsign char of message. Okay, message 1 equals hello. Okay, Message 1 is allow. So copy this. I put the message 2 is embedded system design. Okay, embedded system design. So, and then functions like void, okay, LCD underscore init. First we go for a initialization function and void delay. Let's introduce some delay here. Okay, void LCD underscore command, display LCD underscore command. Okay, unsigned. The input is character. Copy this one. It should be data. It should be data. So this is command and unsigned. First, this is for sending the command, and this is for data. Delay. First, we will write the program for delay. Okay, void of int a. We'll write the program for delay and sign int, okay, int of a for this is just to make a delay. Okay, the slope is for just making delay. So the delay is completed, and then like let us go for command. Okay, let's go for command like P0. It should be P0. Okay, let's go for command void like LCD underscore command. Okay, so I'm giving the command data. Sorry, let us give the command. Okay, so here data equals 0x f0. Okay, f0 0x f0. Okay, so we are taking only the upper nibble. Okay, this is for upper nibble. So you got like f of, you got f0. You when you add this with f0, this is f0. So you get only the upper nibble here. Sorry. Okay. So rs equals 0 and rw equals 0. rs rw. Okay, rw equals 0. And this LCD enable, okay, LCD enable is 1. Yes, 1. Give a delay. Okay, approximately give 35 or 40. LCD enable equals 0. And this data, you send the LCD enabled equal to 0. Now you have to pass the lower nibble. Okay. For lower nibble, you just shift 4. You will get the lower nibble here. Copy this one. Okay. And paste it. This is for command. I just copy this one and again I paste it for data. LC underscore data. Okay. So this I mentioned this is data data. Okay, dat. So this okay. It should be 1 here. Since it is data, it should be 1. The rest is same. LCD underscore data. Command, and this is data. Okay. Then like we go for LCD underscore init. I repeat this code. See, we have declared register reg51.h and std.h and has defined data. We have used port 0. We are using port 0 here. Okay. Like port 0. Register select is P0.0. We have connected register select to P0.0, RW to P0.1 and LCD enabled to P0.2. Okay. Then message 1 and message 2. First line, this is second line. We have 4 functions. One is LCD underscore init, delay, just delay, we put a for loop here. So for one time, like it will be 10 microseconds. Okay. So approx like for executing 1 k value, if k equal to 1, it will be 10 microseconds. So like delay LCD underscore CMD for command and for data, LCD underscore command and LCD for data. Okay. Unsigned char and unsigned char. Okay. So this LCD underscore data, like void LCD underscore data, and we have this unsigned. So the input is like we have to F0 when you AND with F0. Okay, so F0 is this value. So you get only this. You get only this upper nibble on data, and put RS equal to 1 and RW equal to 0 for data. LCD enable equal to 1. So delay 35. So this will send this upper nibble. Then you send the lower nibble, is shifted to 4. Okay, you send the lower nibble. For command, same thing. Okay, for command, same thing. So for command, same thing. Let's go for LCD underscore init. LCD underscore init. Okay. So okay. Okay. So first, like unsigned char of I, declare the I value. Okay. First you pass this LCD command. Okay. LCD command. First you pass the value 0x28. Okay. This is to choose 2x16 LCD. For some LCD you have to put 38. Okay, you have to check the data sheet of the LCD what you are using. Delay. I'm going to give a delay of 15. Okay, delay of 15. So approximately like one is 10 microseconds. So 150 microseconds. So 1 millisecond. Okay. So command and then like delay of 15. The next command is 0c to display on cursor of. To display on cursor of, you copy this line, paste it, 06 and 01. Next is 06 and next is 01. So shift cursor to right and clear display screen. So delay, you give a delay here, like here, like we are going to display. So delay of approximately, like you just give for 5000. Okay. So the next is to display the first message. Okay. To display the first line, message in the first line. To display the first line, you give the command to choose the first line. The command is 80. Just give a delay. Okay. And I equal to 0. Sorry, I equal to 0. You put a while loop. While of message 1. Not equal to single quotes /0. If you put directly 0, if the message contains 0, like the loop will be terminated. Okay, so for that I have used to find the end of the line. To find the end of line, I have used /0. Okay. So LCD underscore data. Just copy this LCD underscore data. Okay. So check for message. Give a delay. Let us check this message first. Okay, let us check this message, first message, and then we will go for the second line. Okay. So now write the main program. Void main. Void. So P0, okay, assign P0 equal to 0, and I just call this LCD underscore init. You get delay, you give delay here. Delay of 10. Okay. Wait while of 1. Save the program. Compile the program. Let us check for error. Okay. So I'm going to open. Let me check here. Let me check on the hardware part. Like I'm going to use what on ICP utility. I just open. Okay. So check for the objects. So we have to create the hex file. To create a hex file, you just choose this option at the output, create hex file. Okay, and recompile the program. I'll explain the program once. First I'll check for the output, whether we are getting the output or not. I'll load the file. Okay, load the file, like I'll check for the desktop. I'll choose desktop and LCD. LCD on the desktop. Okay, objects, LCD hex, and update chip. So before that, before giving update chip, let me open the video. Okay, so this is the one which I have connected. I have sorry, I have given I have this is the display, okay, which is connected to port 0. Has some loose connections here. Okay, connected to port 0. First let me program that one. So for programming, like I have to give update chip, and I have to press the reset button. Okay, I have to press the reset button. So once the reset button is pressed, it detects the 8051 and it erases the previous program and loads the program. Okay, and it's verify the program. Once the program is verified, you get this message: chip is successfully updated. Click OK. Okay, and then let me check on that. What's the message? Reset it again. Hello. Okay, I got it, but the first line, I'm not sure because of the backlight. I think not clear. Let me check. Okay, you're able to see now. Okay. Off the light. I could. The letters not. Hello. Okay. I think it is okay now. Hello. The first is okay. So let me check for the second message. Like let me put the second one on the code. Like I go to the program. Okay, this is message. Okay, this is on this is in this. I just go for LCD underscore init. I just copy this one. Okay, I just copy this line. Okay, I just copy this line, just paste it again. Okay, I just copy this line. So like here I have to modify C instead of 80, like for second line I have to modify C0. This is for this command is for 80 is for first line to display. Okay, C0, the second line is ESD. The second line on the message is ESD. Okay, I just type this is hello world here, and this is ESD. I put this is ESD IoT. Okay, ESD IoT, and this is, I just copy the second message. This message I have to put this message to. Okay, because here we are declared this message 2. So recompile the program. I recompile the program, and I go for the utility. Okay, I load the file again. Before that I open this hardware update chip. I have to press the reset button. Okay, I have to press the reset button. So it is displaying hello now. Okay, chip is successfully updated. I press the reset button here. Okay, so if you check now, like displaying hello world on the top, but the second line is also displaying hello world. Hello world. So there is a here it is message 2. I have not modified this. I have not modified the. I'll show you. Like I have done a mistake. Like I have not modified this. Earlier it was like message 1. Okay. So I have to change this as message 2. Message 2. Okay. Message 2. So now, like, let me recompile the program. I recompile the program, and like I have to update, load the file, load this hex value, and update the chip. Update chip. So I have to reset. I will explain the program one more time, step by step. Okay. Click OK. So if I check now, if I give reset, and if I check now, it is displaying hello world ESD IoT. I will try to show the output. Okay. So it is displaying hello world. Okay. I think now it is what. Hello world ESD IoT. Okay. So I will explain the program one more time. The program is very simple. Like the LCD operates like based on the command and the data. Okay. It has only 3 control lines. It has only 3 control lines. One is like 3 control lines are RS, register select, read write, and the LCD enable. Okay. It is connected to 0.0, port 0.0, 0.1, and 0.2. I have connected to that port 0.0, and the last 4 bits of the port 0 is connected to the data pin. Okay, for the data, last 4 bits. So I have message 1, message 2, hello world for the first line, and this is for the second line. You could have 16 values here. The maximum what you could have is 16 characters. So I have 4 functions. One is for delay, LCD underscore init, for initialization, and for command and for data. Command and data are same. Okay. So delay, just put a for loop here. Just put a for loop. For one value, it will take 10 microseconds. Okay. For example, for k equal to 1, if it increments one time, 10 microseconds it will take. So LCD underscore data, like you mask the data with the F0, so you will get the upper nibble. Okay, upper nibble, and RS equal to 1 for RW equal to 0. Register select should be 1 and RW equal to 0, and LCD enable equal to 1. From 0 to 1, it has to move from 0 to 1. Previously it will be 0. Once you make this one, after the delay you make that as low. Okay, so that when you enable next time it will be from 0 to 1. Then only it will take this as LCD enable. Okay. First you give data 4 value, and then you shift it 4. Shift that value that to 4 to data. So you will get the data value here. You will get the data here. The same function, you just copy and paste command. You just change this RS equal to 0 here. Okay, the rest is same. That's for command. Now coming to the initialization. First, initially you have to send the command for the LCD. Configure what type of LCD is it. 2 cross 16 LCD. The command is 28. In some case, it should be 38. Give a delay. Then send command 0Z. This is to display for cursor. Okay, for cursor. Like the command set is there. The command set is there on the Google. Like if you check on Google, like you will get the command set like 0C, 06, 01. Okay, for clear screen. 01 for clear screen. And 80 for the first line. This is for first line. Okay, for the first line, put a message while loop till the end of the character, like till the end of the character. You should not put only 0, because if you put 0, then if any character is 0, it will terminate the loop. So you put /0 so that it will go for the end of the line, and it displays the data. Okay, it displays the data. Delay 50. Okay, this is for second line. C0. The command C0 is for second line. Okay, C0 is for second line. While message, like it till the it will this will display the till the message 2. Okay, so void main first initialize the port LCD init delay while, so it will stop here. So if you check this one, like so the message will be like hello world ESD IoT. If you want to change the message, you could change the message and recompile the program and download the program, it will work. Okay, so this is the code for LCD. I hope you will be clear, and like you just go through the program again. I will go for the I2C part. Okay. So coming to the I2C part. So coming to the I2C, like we are running out of time. Okay. So coming to the I2C stands for inter-integrated circuits. Okay. So it's a two-way communication. Like if you take UART is a three-way communication. Like you have TXD, RXD as well as ground. Whereas I2C is a two-way communication. Okay. The two-way communication. Give me a minute. Okay. It's a two-way communication. It uses only the clock and the data. Okay. It's a it's an asynchronous, like asynchronous. Okay. Like two ways. Like it could connect up to 1008 peripheral devices. Okay. And I2C is only, like it uses the clock as well as data, serial clock as well as serial data. Only two lines it uses. Okay. And it could connect up to 1008 devices. If you take UART can be connected only for two devices. You could, but if you have, even though if you have option to connect with multiple devices, or with UART, like you will get the bus contention issue on UART. Okay, on universal asynchronous receiver transmitter. Whereas in I2C there is no such issue. Like it could have multiple master and multiple slaves. Okay. Whereas the other protocols like SP, serial peripheral interface, which uses the 4-wire, like it uses like it could have only a single master and multiple slaves. Whereas this I2C can have multiple masters and multiple slaves. Okay, so and like so this is an example. Like it have controller 1, controller 2, a peripheral 1, peripheral. It means the master 1, master 2, and maybe slave 1, slave 2. Okay, so you could, everything is connected on the two lines. So if you check why to go for I2C, like you take UART will have the bus contention. Okay, when you connect multiple devices, like more than two devices will attempt to drive the same line. Okay, so that will get bus contention issue on UART. Whereas that's a disadvantage of the serial port. Whereas when you go with SPA, okay, like this is when you go with SPA, like this is SPA actually. The disadvantage of SPA is like you need additional GPIOs. As well as you could have only one master and multiple slaves. Okay, so that's a disadvantage of serial peripheral interface. But I2C is like you could have multiple master and multiple slaves. And another option is like I2C has open drain. It's open drain. So since it's open drain, you have to put a pull-up resistor for on both lines, on serial clock as well as for serial data, so that it will be like, because it's open drain can drive the signal low, but it cannot drive it high. Okay, so you put a pull-up resistor so that it will be always high when it is not no issue, so that you could avoid the bus contention issue. So you have to, since it's open drain, you have to put a pull-up resistor on SCL line as well as the serial clock as well as some serial data. And the features, like it's half duplex. Okay, like bidirectional communication is possible but not simultaneously. Okay, so it's half duplex communication protocol, and it's a synchronous communication. Like it's based on the clock. And arbitration, like it has arbitration, like if any master communicates, the other can understand and it stops transmitting the data. Okay, so that it could have multiple master, multiple master, and it could judge like if the serial data is if the SDL if the SDA line is found high. Okay, so the other master, so it could understand, the other master can understand the some other master is active, and hence it stops transfer of data. So arbitration is there. So serial transmission, like it is for low speed communication within a PCB communication. Okay, to connect with multiple I2C devices. It could connect with like more than 1,000 devices, and it also has clock stretching. Okay, clock stretching, like if the slave is not able to accept the data, it stretches, like it could control the line, SCL line, okay, to tell the master to it is not ready for the next bit. So that's clock stretching. Okay, so the start condition, it has the start and the stop bit. The start condition, like when the line SDA lines goes from high to low, okay, and SCL should be high at the time for a certain period of time. After that, both goes low. Okay, that condition is called start condition. If you check on this timing diagram, like SDA is high and it goes to low, suddenly it goes to low, and SCL is also high at a time. When it reaches the low condition, then SCL also goes low. Okay, so this is called start condition. The stop condition, the SDA, the stop condition, like first the SCL goes high, then SDA also goes high. Okay, then that condition is called stop condition. Okay, start and stop. Okay, so to know how I2C works, okay, like the master device sends a start condition. Okay, first the master device will send a start condition. If any one of the masters started communicating, then the next master will be like it won't send the start. Okay, it won't send the data. It won't send the start condition. Okay, it will understand and it will wait. So the master device sends a start condition. Okay, so like it sends like once the start condition is there, then like it like the I2C, like the master will send the address. For example, if it wants to transmit the data to the slave, it sends the address of the slave, okay, first, and then it waits for the acknowledgement, and then it sends the data. This acknowledgement will be controlled by the slave. This acknowledgement bit will be controlled. This part will be controlled by the slave. So if you check, when you send the data to the slave device, the blue color line indicates these are the bits which was controlled by the master, whereas the white color line was controlled by the slave. Okay, the acknowledgement signal is controlled by the slave. So the master sends a slave address that is 7 bits. Okay, and the data bits data is 8 bits. Okay, the slave address is 7 bits, and the read write, whether it is read operation or write operation for that 1 bit. So totally 8 bits. 8 bits, and the acknowledgement bit that will be controlled by the slave, and the data bits is 8 bits. Again, you will get the acknowledgement whether the slave is received the data or not. Okay, that is also controlled by the slave bits. The white color indicates it is controlled by the slave. Okay, the blue color indicates it is controlled by the master. Okay, stop bit. So start and the stop bits to send the data. So if you have 10 device, the device which has a say address will respond the acknowledgement signal, and it gets the data. Okay, if this is sending data to a slave device, to reading a data from a slave device, okay, the master controls the master sends the address, gets the acknowledgement, and the slave will write the data. Okay, the slave controls the data bits now. Slave controls the data bits, and the acknowledgement will be done by the acknowledgement will be done by the master, that is NACK. Okay, NACK, before that it is ACK. And so for write, like it is NACK. NACK will be controlled by the master, and finally it gives a stop signal. Okay, so this is how it works. Like if you check here, if you check on this timing diagram, for the older version of the I2C is 7 bits, the initial version, but now it also has 10 bits. Okay, so if you check here, like this is a start condition, then it sends the 7 address bits, then you get the acknowledgement. okay, which is controlled by the slave, okay, which is controlled by the slave. Then you get the data bits. After that, you get the acknowledgement signal again. Okay. Then you get the stop signal. Okay. This is a timing diagram of the I2C. The code is very lengthy. Like, I'll explain you the code. I cannot type this code one by one, so it will be very lengthy. So I'll copy the code and I will paste the code by function, and we will execute the code. Okay. So first I will explain you the code on the presentation. Then we can go for the we will go for that KEL. Okay, KEL. So you have reg51.h, stdio1.h is for printf, for using printf, and intents.h for using NOP operation. Okay, for just for delay NOP operation. Has defined ACK is 1 and no underscore ACK is 0. Okay, you have to define this one. Declaration for the E data, like EEPROM data as well as data. Init, serial and delay. Okay, these are the functions. Like, you have write I2C function and read I2C function. To write it on the I2C and to read from the I2C, we have two functions. This serial is for seeing just for visualizing the data on the serial port, the same thing which we covered up on the UART code. Okay, delay is nothing but the same thing which we covered up in the previous program. Delay, just a for loop. Okay, and like void start and stop to generate the start signal as well as the stop signal. Okay, and read byte and write byte to read the byte from the memory. So we are going to use 24C04 I2C. That's an EEPROM. A lot of you could use for memory, you could use it for temperature sensor, or you could use it for different devices. Okay, different devices. Even for LCD, you could use I2C. There are I2C LCDs there. Okay, so that you could use only 2 lines instead of using 8 data lines or 4 data lines. Just by using 2 data lines, you could display the data for LCD. So I'm going to use 24C04. Data sheet like I2C EEPROM memory. So we are going to go byte by byte to read. We are going to write the byte as well as for read byte. For that, I have used 2 functions, read byte and write byte. Okay. So I'm connecting SCL to 2.0 port 2 at 0th pin and port SDA to 2.1. And this is the same thing. Init serial functions, like to set the SCON registers and TMOD registers and the TH1 and TR1 timer 1 on. To set up the serial port and the baud rate of 9600 baud rate. Okay, TH1, the same thing which was explained on the UART code. Like, you could use you could find it on the yesterday program. And like the start. Okay, the start condition, if you check the start condition, the SDA line. Okay, the SDA and SCL line. The SDA and SCL line are pointed to 2.0 and 2.1. To make it this 1, SDA is 1. Okay, SDA is 1 and SCL should be 1 for a certain period of time. After 2 NOP, like 2 microseconds, after 2 microseconds, this, if you put 2, it no operations. NOP like 1 microseconds. Okay, NOP will take 1 microseconds. So after 2 microseconds, like, it goes from SDA line goes from 1 to 0. Okay, 1 to 0, and is like 1 to 0. After 2 microseconds, SCL line will also go to 0. Okay, this is the, and after that no operation. So this is the start signal. You have to generate the start signal. Similarly, for stop signal is 0 to 1, no operations. So it will go for SDA line go from 0 to high, and SDA will be always in 1. That's the stop condition. It is here, actually the stop condition is here. Okay, this 0 to 1. I'll copy this one and put it on this. Okay, so SCL and SDA. So write I2C, like this is to write the data, and this is to read the data. Okay, for writing the data, like you have like it is totally of 8 bits. Okay, it is of 8 bits. This is data. And yes, okay. This is data. Okay, 80. This is data SDA. So we have to send the data on the SDA. Okay, so what are the data you get? You put into 80, like you'll get the least like MSB, like you will get the MSB as 1, and this will be continued, like you have to like this will be continued for all the 8. Okay? You have to pass all the data. Every time you'll be shifting the data like one shift. You'll be shifting the data one shift, and you put SCL equal to 1 and SCL equal to 0. Okay, SCL equal to 1 and SCL equal to 0. So this is to write, and for read, like you have to, for read, like you have to write the address first. Okay? You have to write the address first. Address is 0 into A1. This A1 you will get it from the data sheet. Like I will show you the data sheet. Okay? The A1 will be A1 you will be getting from the data sheet. I'll show you the data sheet, like ESD master class. Okay. Data sheet of 24604. Like you have the address line, like address A0, A1, A2. Okay, and address line, like, so that should be, okay, this is the, like, this is the one. Okay, this is the one, device address. Okay, it is on page number, the page number is 7. Okay, on 24604 data sheet, the device address you have for 2K device, like 1010. Okay, 1010 to 8421. So that's 10 A. Okay, the rest of the thing is 0. A2, A1 and A0 is 0, so it should be 0, 0, 0, and read will, if it is read operation, it will be like when the micro, like read, like it will be 1, and write it will be 0. So okay, so A1, okay, read it will be 1, and for write it is 0, so it should be A1. A1, and like you send the data, you send the, like you put a for loop. Okay, you put a for loop, and like you send you send the data here, and then like you to read byte and write byte, to read the byte from the I2C as well as to write the byte from the I2C. Like you have to shift this address. Okay, and the delay is same thing, and the main program, like this is the location, starting location, like I'm going to write 8051, write I2C 80, write I2C, I am going to call the function write I2C 8051. Okay, and delay milliseconds of 10, and read byte and read I2C, and again I'm going to read the data, and I'm going to display on the UART. This is the one which I'm going to show, that like init the serial port, initialize the serial port, play the hyperterminal, write, we have to write the write byte from this location, write I2C 8051 byte. It is byte by byte writing. We are going to write byte. There are two options. You could also write page wise, but in this program, like we are used only byte byte based. Like we are writing the byte and reading the byte. Okay, byte based addressing. So write byte of 8051. Let me open the program. Like I'll go with the program with the previous program. Okay, so you check, this is a program. This is the program. Okay. So I compile this program. First I'll compile this program, and I will download, and I will show you the output. I open the ISP utility. I also open I will open the demo part. Okay. So load this file. Okay, just copy this path. Load the EEPROM file, click update sheet. Okay, so you have to press the reset button. So once I press this reset button, like it will erase and it will program the new version of the file. I am just opening the UART now. Okay, so serial port terminal. I'm opening the serial port terminal. So choose the serial port, go for terminal, and like just reset. Okay, so this is the data which was written on the memory. Okay, this is the data which was written on the memory. So I will explain the code one more time. Like this is to declare the register for the header files. Okay, for using this NOP operations, you could just type entrance.h on the Google, and you could check entrance.h the Kale. Okay, so which has the pop. Okay, so we use the NOP. Okay, we use this NOP, no operation. So ACK, this is declaration like write I could see, read I could see, start and stop, read byte and write byte, and delay. Okay, declare this ports, main program, initialize the serial port. This is just to clear the hyperterminal. Even if you remove this line, it will work. Okay, write byte. So write I could see 8051. Okay, this is the value which we are going to write, and stop, issue stop command here, delay milliseconds, and read the byte from this location, read I could see. So which we are displaying on data 1, data 2, data 3, where we put a for loop to print it on the UART. Okay, to print it on the UART. So while of so the init serial port, like this for initial, this is the code for initialization of the serial port. This is the start, void start. This is the start command, and this is a stop. Okay, and this is the write I squared C. Write I squared C, like which writes which generates the data. Okay, and this is the read I squared C. You will be first sending the address first. Okay, A1. Okay, for read byte and for the write byte, this is to read the byte from the memory, and this is to write the byte from the memory. And this is a code for delay. Okay, code for delay to give a millisecond delay. So for we are using 11.059 megahertz. So it should be, the I value should be 1 ton. So for every count, it will take 10 microseconds. So it will give you 1 millisecond delay. This code will give you 1 millisecond delay. Okay. So with this, I close the session. So thank you for your time. Like see you on the next session tomorrow. And the internship is going on. Like if you want to enroll, you could enroll. Thank you for your time. Like see you in the next session. And until then, bye bye.